Welcome in. This is our first video on combining like terms. So we're going to look at this algebraic expression. It's 2x squared plus 3x plus 3 plus 4x squared plus 10 plus x. Now before I toss in my algebra tiles, I want to visualize like what are each of these terms going to look like. So I need 2x squared, I need 3x terms, I need 3 ones, I need 4x squared, I need 10 ones, and I need 1x term. So visualize that maybe for a second and then dive into your pile of terms and visuals. So there are my 2x squareds, there are my 3x's. This doesn't look right, does it? I have 3 ones, but one of them is negative, so let's make those 3 positive ones. Here I've got 4x squared, so I'm going to stack those on top of each other. And then over here I've got 10. And what I chose to do was instead of 10 ones, I have 2 groups of 5 ones, and then that last term is an x. So we're going to combine like terms. Like terms means those are terms that have the same coefficient, and sorry, I misspoke. Those are terms that have the same variable term. And visually we can see what looks the same. So in this case, I'm going to start with what's on the left. I've got 2x squareds, and I can clearly see that I have 4 more over here. So if we combine those, we see that we're going to get those over here, and we've got a total of 6x squareds. Nice. All right, let's move these ones over here, because guess what? Might as well just make it easy on ourselves. Just group everything that looks the same. Okay, now, so I've got 6x squareds, so I can rewrite that as 6x squared. I've got 1, 2, 3, 4 x's. I can write 4 x's underneath it. And then, just for the sake of my thinking, I just like grouping them, and then I can go back and clean all this up. So I've got 10, and then 3, that's 13 ones. Okay, and I wrote these in descending order in terms of visually their size. Like this is the largest piece, then the next largest piece, and then the smallest piece. We got to remember that these are 5 ones. These are 5 of these little guys. So these are not bigger than the x terms. Okay, so I've got 3 terms now. I went from, gosh, a total of 2, 4, 6 terms down to 3 terms. The reason why was I could combine like terms, right? So my final expression is going to be 6x squared plus 4x and plus 13. Now, visually, we knocked it out of the park. If we go back to our original algebraic expression, we can see here that we can identify our 2x squared terms. We would go 2x squared plus 4x squared, and then we would look at the coefficients. So when I said earlier that word coefficients, we're looking at the numbers in front. So we've got 2x squareds and 4x squareds, and that gave us our 6x squareds. All right, now if we move on to our x terms, we see here that we have 3 x's, and then over here we had that 4th x all by itself. So if we rewrote that, we'd have plus 3x plus x. And of course, we could put the 1 in front just to remind ourselves, and 3x plus 1x equals our 4x's right here. And then we're left with our ones terms. I'm realizing something here, everybody. I could put a box around the x squared so that I know I have a x. And then for my single terms, for my single x's, I could just put a line underneath it like that, like for the x stick. And then I've got my ones, my 3 and my 10. And we've got plus 3 plus 10, and that we know that that made that 13. Okay, there's video 1. Thanks for checking it out. Check out video 2. It's got a little twist to it.